Assalamualaikum warahmatullahi wabarakatuh. My name is Luqman Al-Hakim, and I, as of the rest of my other group members, are from class 68B. So today we are going to be showing you a video on our mini project, which was titled Water Quality. So a brief explanation on our mini project. We have decided to go with three models with different ratios. So these ratios comprise of charcoal, of sand and pebbles. Alright, so for the materials used for the water filter, we decided to go with charcoal, sand, pebbles and also cotton. Now, why do we use charcoal? Now the reason why we use charcoal is because charcoal has the ability to absorb impurities in water. So charcoal can remove chlorine and also nasty odors. And now, as we all know, nasty odors are bad in anything. What else? Water, right? Okay, so next we have sand. Now sand are fine particles, and basically their job is to trap the less finer particles in water into the sand. So basically when the water flows down the sand, the fine particles will be stuck in the sand, and these particles are mainly not seen with the naked eye, so it's a good thing sand is there. Now next we have pebbles. Pebbles are also the same thing, but instead pebbles are larger than sand, so that means pebbles can trap the more larger particles, meaning these particles could be seen with the naked eye. So because of that, pebbles and sand are chosen for this water filter. Lastly, we have cotton. Cotton is basically there just to hold everything in place.
Okay, now we continue with the apparatus needed for this experiment.
First, we need a 2 liter of water in a container with lid.
The second material needed is soil. And lastly, we need a spoon.
For the model setup, the important apparatus needed is 2 empty plastic bottles,
5 pieces of cotton pad,
pebbles or aggregate,
sand. Next is charcoal. The finer the charcoal, the better. Lastly, a cutter.
Firstly, we need to prepare scientific raw water by mixing 1 tablespoon and 1/3 of soil into the 2 liter of water.
For model type 1, the ratio of the charcoal, sand and pebbles is 1:2:1. After compacting the cotton pad as the first layer, we need to fill the activated charcoal as the second layer.
we need to pour the charcoal until it reaches 4 cm height.
For the next layer, we will fill the sand in the bottle until it reaches 8 cm in height.
This is the third layer, which is 8 cm of sand.
For the last layer, we will place the pebbles until it reaches 4 cm height.
This is the last layer of the filtration system for model 1.
Next is for the model preparation. Firstly, label A and B on the different empty bottles. Measure and cut at least 3 cm height of the bottom part of bottle A using cutter, and then clamp 5 pieces of cotton pad and compact it at the top part of the bottle through the open cut section. For the second, third and fourth layer, add the activated charcoal, sand and pebbles respectively according to the ratio divided that is discussed on our group. Our group decided to make 3 different types of model with 3 different ratio of each material for each layer. Furthermore, cut bottle B into half by using cutter. Remove the half top part and only use the bottom part as the container to capture the filtered water. After that, remove the cap of bottle A and place on the bottom part of bottle B. Shake the synthetic raw water before carefully pour 1.5 liter of the sample in the bottle A through the cut section. Let the water sample travel through the filtration layer until no water sample is left in the filtration.
For the third design, we use 5 pieces of cotton balls and 4 cm depth of charcoal, 4 cm depth of sand and 8 cm of gravels. So this is the before and after using the third design of water filtration.
To decide whether the filtered water can be used as the non-potable sources, we need to check the physical parameter of the water.
To determine the turbidity of the water, we will use this turbidity chart called Sassy-Tees chart. This thermometer will be used to check in the temperature of the water. To check the pH level, we will use this pH strip. This A4 white paper will be used as the background to comparing the color of the water. 2 small plate, 2 clear cup or clear container, and the last one, syringe. Fill 50 ml of filtered water and sample water into different containers and place it side by side. Hold an A4 white paper as the background to compare the color between of both samples. Fill 10 ml of filtered water in small plate using a syringe. Dip the tip of the pH strip and let the pH strip change the color. Compare the color of the pH strip that was dipped before with the pH level color. Repeat the same process with the sample water. Fill 10 ml of filtered water and sample water into different small plates by using a syringe. Scan the temperature of each sample.
First, we need to fill 50 ml of the sample water into a clear container.
Place the clear container on the first dish. Stir the sample until all the sediments settle down at the bottom of the container. Keep moving the container until the black and white section cannot be distinguished anymore. For this sample, the turbidity of the sample is 100 JTU. Repeat the same process with the filtered water.
Okay, so we're back with me. So the reason why we're making these water filters are mainly for non-potable use, meaning that it is not for drinking purposes. It is mainly for livestock and irrigation. So that water doesn't necessarily have to be super clean, but enough to be used as livestock and irrigation. Although the results from the 3 models were quite similar, but I think we can confidently say that Model 2 was the best among the 3. This is simply because of the fact that Model 2 had the more clear water. This is mainly due to the fact that Model 2 had the most amount of charcoal compared to the other 2. And like I said earlier, charcoal has the ability to absorb impurities. So due to this fact, we believe that Model 2 was the best model among the 3. Okay, so that's all from us. I thank you for listening. Assalamualaikum warahmatullahi wabarakatuh.